In this video, we'll try to conclude number 4 from the 2001 AB exam. It's a non-calculator question, and in part C here, we want to write an equation for the tangent line to h at x equals 4. So if we want the equation of a tangent line, we're going to need to either use point-slope form or slope-intercept form. We're going to need to know a point on the line, and we're also going to need to know the slope of the line. Well, since it's a tangent line to the graph of h, the slope of the tangent line is going, evaluated at x equals 4, is going to correspond to the value of the derivative evaluated at 4. So if we go ahead and evaluate our derivative at 4, we're looking at 4 squared minus 2 divided by 4. And so that's going to be 16 minus 2 in the top, so 14 in the top, 4 in the bottom. And if we go ahead and reduce that, we're looking at 7 halves for our slope. So the slope of our tangent line is 7 halves. Now the point of tangency, the tangent line has to hit the curve at the point of tangency. They've given us one point on the curve. It's the point 4 for x, negative 3 for y. That means that our tangent line intersects the curve at 4, negative 3. So all we need to do to wrap this up is need to write the equation of a line with this slope that goes through the point 4, negative 3. So if we go ahead and use point-slope form here, I'm going to do y minus y1. So I could do minus negative 3. I'm just going to change it to plus 3. And that's going to be equal to m, which is 7 halves, times the quantity x minus x1. That's the x coordinate of the point that we know is on our line. So there's the equation of the tangent line in point-slope form. If you preferred to use slope-intercept, that's obviously also fine. In the last part of this, we're asked a question about the tangent line that we just found. Does the line tangent to the graph of h at 4 lie above or below the graph for x's that are bigger than 4? And then it wants us to try to figure out why. Haven't really done anything quite like this yet. Let's think about what we know here. We know we're going to have some function h graphed. And we know that on the graph of h, when x is 4, y is negative 3. So when x is 4, y is negative 3. So we know that our tangent line and our curve intersect at this point. We know that the tangent line has a slope of 7 halves. So I could use, rise over run here. I'm just going to draw a line with a positive slope, right? And that's something that I'm using from the previous part that we just discussed. Slope of this line is 7 halves. What does the curve look like, though? We don't really have the function provided to us. We do have some analysis that we did in part B that's going to be useful to us right now, because what we determined in part B was that our function was going to be concave up on its entire domain. On the interval that 4 is included in, which would be this piece of the sign chart for h double prime, the sign of the second derivative is positive. So we need to have a graph in part D that's drawn with a slope of positive 7 halves at this point. So how are we going to draw our curve in? We have to be concave up, that would mean that the second derivative is positive on this interval. So h double prime of x is greater than 0 when x is greater than 4, right? It's actually greater than 0 for all values in the domain of this function, but we're just asked to consider the piece of the graph for x is greater than 4. So since our second derivative is positive, the rate of change of the first derivative is positive. And if the rate of change of the first derivative is positive, that means the slope of the tangent line is increasing as we work our way across this graph. So we're going to have a graph that's increasing and concave up. That's got to be a point of tangency. And since the graph needs to be concave up, I need the slope of the tangent line to get steeper as I go past the x value of 4. We're going to have a slope of 7 halves at 4, but then the slope on the other side of 4 has to get steeper. It has to get bigger than that. So does the tangent line lie above or below the graph of h? Well, the tangent line lies below the graph of h since h of x is concave up. If h of x would have been concave down, we would have had a graph that would have looked something like this. The slope of the tangent line is going to have to decrease as we proceed to the other side of that value, and this would be a situation where the tangent line would be above the curve. So concavity, as you move away from the point of tangency, is going to tell you whether or not the line is above or below the curve on that interval.